So it's quite a high pressure time. But the worst thing to do right now would be to humble. So I thought, I'll make a study book for today, and hopefully that will put a bit of my steps to keep going. So working on physics 3 right now, I'm just doing every single paper basically. I've done them before, but I then have left them alone. I think enough that I've forgotten them. I think some of the questions I've done do I've accidentally, but that's I'm currently a bit stuck on question 5 of November 2020 about this. I don't want to look at the answer because I want to be able to figure it out. It's the way it is vertically polarized, and it's being transmitted from an AC supply, and then the receiver area requires a diode, and the question is, why does it require that? What the diode for to detect a signal at that point. I thought perhaps it's to do with the fact that there are oscillations, even though it's being vertically polarized, there's still oscillations in both planes, an electric plane and a magnetic plane, and somehow that would interfere with current, or I'm not sure. Anyway, so I'm working all today. I'm stopping at about 2 to go swimming. It's gonna be fine. It's really dark in here. My light broke, which is making it slightly harder to work. And there's a lovely calming rain outside. I'm really enjoying this weather, and it makes me want to just sit and stare out the window and think, and not do 30 past pages. But I'm lucky enough to have a very nice window, so I can do both at the same time. We got this, I got this, you got this. Final sprint. It's not that long, and we're going to do really well. Okay? You will, I will. Nice. I'll catch you on the flip side. Okay, so just on this question 5 that I was stuck on, I think I was way overcomplicating it, because Mark's scheme, it says for that bit about why a diode is required to detect that current, it's because ammeters will only detect DC current. I was thinking about it as if, it's still going to detect like a net, because an ammeter is only going to detect the net flow of charge, which in an AC circuit is 0. so that was all. I mean, all you actually had to say is a diode only that's current passing in one direction, so you don't know you're beautiful, and that's what makes you beautiful, and don't overcomplicate it. Okay, for part D, I found this a lot harder. It was a 6 marker, but not like a kind of traditional practical 6 marker. It was two setups for experiments. The first was rotating the receiver, which kind of makes it, I think I did touch on what they were trying to say. It's more to do with okay, so a receiver it will, because it can only detect in one direction, it will detect that you don't know you're beautiful, and when electrons are oscillating in one direction or in another direction, and the receiver arrow will only detect it only in the vertical plane. Receiver aerial horizontal, electrons are driven across the aerial because the oscillations are only in the vertical plane. Okay, so only when it's like this is it going to detect it, because that diode will only detect in that direction. And so when it is, only at this point it's going to detect. So rotation of receiver by aerial of +90 to 70 from vertically to 0 current. Okay, so when it will detect, it's unusual that it will detect it like that when it's been polarized. Maybe it's just that you know that it's a minima at this point, and so you don't need to think about it too much. Rotation of receiver aerial by 90 or 270 leads to 0. Okay, that's when it's oscillating in the other plane, so that will give us a minimum. I think the rest of the directions, I think because it's polarized, it's still gonna oscillate in a certain only in this direction, but it can't be received because it's not understand. Okay, so there's 0 rotation here. The second experiment, I thought it might be something to do with photoelectric effect. It was not. Because there was a metal sheet placed behind it. Well, if maybe electrons are arriving at their maximal displacement, that will be the threshold frequency, and then they'll be able to emit, and somehow no, I was also making, the reason this was wrong is because I realized I'm making too many assumptions that when electrons are emitted they will be able to join that circuit, that when also that the phase of a wave will determine whether or not electrons are emitted, which is not true, because in photoelectric emission we model light as a particle, so that was wrong. It was actually that they will be, that I think when we hear reflection, need to think of superposition, and then when they arrive in and out of phase, it will give a max current. So we have incident electromagnetic wave and then a reflection. When those two arrive in phase, it's a max current, and then they arrive in phase. Okay, I think the lesson to be taken from this question is don't model photons or electrons for that matter as both particles are moved in one question or one thing, because we can't really do both electrons to both. Also when you don't make lots of the other things. the conservation of momentum. Basically, that was the last bit. And that when, so if you think about it, so they have a nucleus deflecting an alpha particle Rutherford experiment, but it's exerting a force this way. So to conserve momentum, that the nucleus momentum does have to be this way. It's not what I thought was this way. It's not that particle deflected, and so the only change in momentum here. It's not because the force didn't act this way, even though it looks a bit like that when you just model it like that, because the force acted this way. Because it was horizontally accelerated as well. So basically, momentum is opposite. Change in momentum is opposite to in direction to the force that thing exerted. Basically, okay. That's that paper done. I think I need to look through. How many other questions did I do today? Oh, just the one. I think let me just do that now. Question 4. What was question 4 about? Oh, it was about the things here. There's no reaction. Weightlessness experiments for no reaction force. Note to say between the astronaut and players was I don't think I did. That was just to show that question about energy. 1.5 yes, I did. That was just a lot of maths. Power and yeah. Blah, 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 blah. I think that was all I was Chinese balls. I think the question before that I asked one of my teachers about something about capacitance and resistor and getting confused. That was in question 2 or 3. I thought that something must violate conservation of momentum, of energy, but I guess I'll figure that out. I wonder if he's responded to me. He hasn't. Hope he does before Monday. Okay. Probably time to start another paper. Okay, quick point to note. The future exam technique that I did not realise that I definitely would have got this wrong or got you confused. This graph is saying, use this graph to show the output power of the electric motor during this period in about 4 megawatts, yeah? Instinctively, enjoy the from here up to when I was calculating the area under this graph, I was getting about half of that, or just similar values but not quite. Why it's different is probably just because this isn't exactly a straight line. There is some variation in the gradient, so and also the fact that it was 3 marks as well is probably inferring that constant. So yeah, make sure if you're publishing that question and you're not getting the answer that they're asking for, I think. I mean, either way you should do your best to read it carefully, but you know, we have to be quick and necessary. And that's a mistake that I made, and I don't want you to make, and I certainly don't want to make any of them. Okay. Okay, so I just got dressed, I'm ready for the parade, then after that, country swimming. There might be a little bit in series as they clearly are. The reason for this is confusing me a lot. Because this question this shows that this equals this. I did this correctly, but ended up with it basically reciprocated. Because I modeled these two as being in series. The reason that they are not in series, I think maybe it's these, because you can see these ones here, there's a break or a junction occurring at A at B, it suggests that they are in parallel. I can think, well, first, this voltage has to be the same for all three here at any point. So, since after they know I just have to ask you to, and he keeps on saying, essentially, the difference between them because all the rest of them is so essentially, rather essentially in real life, in order to not violate the conservation of energy, power is dissipated in resistances that we've assumed as being negligible. I'm not satisfied with this, and if I didn't have an A-level in 2 days, I would research this further. I think, also the next part of the question confused me a bit, but I think it's a bit easier once you've just taken it that these two are in parallel, and then between C0 and S we introduced a resistor. Logically, there shouldn't make any difference to this